Hi everyone, this is Sherman Gittens, and I'm going to do this systems of differential equations initial value problem. And so we're going to jump right into it. We're going to find the determinant first of A, which is our A, minus lambda, identity, and it's all going to equal 0. So let's put it in terms that we can understand from the matrices. So here we go. So the identity equals the matrix 1, 0, 0, 1. So it just helps us know what we're doing here. So lambda times 1, negative lambda times 1 is 1, negative lambda, negative lambda times 0, 0. So I'm just going to write out here, negative 7 minus lambda. 4 stays the same, negative 6 stays the same, and then 7 minus lambda. Now all equals 0. So when we do the cross product, here we get this. So we got negative 49, and was that negative, so negative 49 minus 7 lambda, and then plus 7 lambda plus lambda squared. And then here, you gotta make sure that you make this negative whatever you get here, so this is plus 25. And then all equals 0. So we have lambda squared, these cancel out, and then this is negative 25 equals 0, equals 0, yeah. Negative 25 equals 0. Okay, so right here we see this is a perfect square, so we have lambda 1 equals 5, and then lambda 2 equals negative 5. Okay, from there, now we are going to use another equation. So A, so we're using our this one, but now we just are using K. And then K is a vector. So K1 is going to be our first value, and then it's going to be 0, and 0 is a vector. So it's going to be 0 for the x and y axes. So we know we have this, but now we're just going to substitute the lambda in for it. So we got negative 7 minus 5. 4 stays the same, negative 6 stays the same, and then we have 7 minus 5. That's times little k1, k2 equals zeros. So from here, solve it out. It's negative 12, 4 is the same, negative 6 is the same. This right here, got 2. Little k1, little k2 equals our zeros. So right here we can tell that the ratio that we have for K1 and K2 is K1 is actually going to be twice the amount of K2. So the way we're going to write that is K1 minus 2K2 equals 0. And that's without having to do all the math and working it out. We know that the ratio is this. It's going to work out to be this. So this makes it that K1 equals 2K2 little K2. And so for big K1, we're able to say that, so if we said that K2 is 1, that means that K1 is 2. So that's that one. I'll hop back up here, and we're going to do the same thing for our second value that we're going to have to get, because we have two values here. We're going to have two values. So we had three values there. We had three values. So let's go through it. So this might be a little confusing. I didn't label that 1. This is 2. The identity stays the same. K vector, second one. Okay, same process here. Plus 5, because it's a negative, 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 plus 4, negative 6, and then because it's plus again, so 7 plus 5. Little k1, little k2. Okay, work through this. So we obviously get negative 2, negative 6, 4, 12. Throw our little k's in there. Sorry about the handwriting. Okay. So we see here that that K2 is 3 times what K1 is. So for that, we're going to say we need 3 K1s to just make 1 K2, so we get 0. So 3 K1 equals K2, big K2 vector equals the matrix. So if this is 1, K2 is 3. Okay. So now this is our general solution. So the vector y equals y of t equals c1, and then our first k value is 2, 1, e to the whatever our first lambda value is, 5t, plus c2, our k2 value, 1, 3, and this was negative 5, so e to the negative 5t. So this is our general solution right here. So now we have our initial value, which said that y of 0 equaled, let's look at it back up here, so 2, -4. So put that in here. So we're saying that the vector y of t equals 2. Don't need that. It's not divided by. Saying that we have 2, -4. Equals. Now since t is 0, this is going to be 1 and this is going to be 1. So we're just going to distribute in here. So it's at 2c1 and then c1, brackets around, plus c2, 3c2. So from there, I'm going to write out the problem 2 equals 2c1 plus c2. I can already tell from here that I'm going to have to solve for c2, so c2 equals 2 minus 2c1. Okay, and so now we have -4 equals c1 plus 3c2. Plug the c2 in there, so we have -4 equals c1 plus 3 times 2 minus 2c1. So -4 equals c1 plus 6 minus 6c1, got -10 equals -5 c1. c1 equals 2. So c1 equals 2, so c2 equals 2 minus 4. 2 times 2 is 4. So c2 equals -2. So now we got to plug that in here. And then so c1 is 2, 2, 1, e to the 5t plus, so actually it's going to be a minus 2, 1, keep putting that in there, it's just 1, 3, e to the -5t. And if we distribute that through, then we'll get our final solution. Which is going to be 4 x value, 2 for the y value, e to the 5t, minus 2, 6, e to the -5t. Okay, there's our answer. So this is the initial value problem solution. So go through it. make sure that you are cross multiplying properly in the beginning, that you're making sure that you look for the patterns where you got them to make your life easier, and make sure just to do proper algebra. If you have any questions, let me know. Thanks for watching.